All right, welcome. So in this video, we're going to expand further on the topics introduced in the first video on image rotation and talk about how if you'd like to rotate and scale your images to match that of your game, how to maintain the pixel quality when performing those rotations. And hopefully you'll be able to, after this video, get your image rotations to look as clear as the rotation of this barbarian image that we have on the left of the actual barbarian entity in our game. So let's go ahead and get started. So hopefully a lot of this code that you see here in our rotate image function looks similar to what you saw in the first video on rotating images in JavaScript. One of the main differences you'll probably notice is that we provide a scale parameter here to this function. The main reason being is that when we're trying to preserve the pixel quality of an image that we'd like to scale and rotate, the order in which we do those two things becomes very important. And this is something that I found after quite a bit of trial and error, but I ended up finding that we need to first scale the image that we'd like to rotate before we rotate our canvas and draw the scaled image onto it. Because if we do things the other way around, we get some rather interesting quality results, and that's something I'll demonstrate right here. All right, so this is what things look like if we choose to draw the normal sized image onto a rotated canvas, restore it, and then try to scale that returned canvas. And as we can see, the quality on this rotating image is way less than what we saw earlier in this video. And the one that we saw previously is if we choose to first scale the image that we'd like to rotate and then draw that scaled image onto our rotated canvas. The only caveat here with this is that if you rotate a canvas, draw an image onto it, scaling that canvas later on is going to cause some quality issues. And so scaling the image first is going to be your best bet. All right, so I quickly want to take a look back at our rotate image function and talk a bit about how this scale parameter here is coming into play as we scale our provided sprites and then draw them to our rotated canvases. So because it's more convenient for the way that my game works out, having square sprites, I'm creating a single dimension value that is the maximum of the width and height of our sprite that's provided. Should we happen to receive a rectangular sprite that isn't square, then this dimension, this maximum call here, will take our maximum of our width and height and always create a square off-screen canvas that is width of size dimension and then height of size dimension as well. And then we're going to multiply that by our scale parameter here to give us the scaled off-screen canvas that will then have our scaled sprite painted onto it. As a reminder, we're then going to grab our 2D off-screen canvas context here. More on this line 71 here in a second. This is also an important attribute to talk about. Um, we're then going to save our context state. I'm choosing to translate about the center of our off-screen canvas here, so that explains the width divided by 2 and height divided by 2 translation. We're going to rotate by our theta value, which is provided in radians. We're going to translate our off-screen context back to the point 0, 0, where we were before the first translation. And then to account for a square or rectangular sprite provided, I have this little ternary couple of expressions here. Should our width multiplied by our scale be less than the dimension, meaning that if one of these pass, then that means that our sprite was not originally square. And to account for this, we're then just going to take the difference in dimension and width or height times scale and divide it by 2. And this will ensure that our scaled image is then going to be centered on the off-screen canvas in the end. And then we're going to draw our image to be size width times scale, height times scale. And this will ensure that we are scaling our image before restoring our canvas, and this is the important part that maintains the quality. Finally, we're then going to return our off-screen canvas, which is essentially an image replacement and can be used as a sprite sheet replacement in our ctx.drawImage calls that we have within our game entities. So the final piece that I want to touch on in this video that isn't exactly related to image rotation, but is very much related to sprite pixel quality is this image smoothing enabled value. This value by default is set to true for all canvas contexts, but we actually would like to modify this value, and the reason being is, let's go ahead and take a look at a demonstration of when this value is set to true here and see the difference in quality. All right, so as you can see here, this is quite a bit worse looking than what we had at the start, and the image smoothing enabled is basically preventing the sharpness of the pixels from coming through. It's an anti-aliasing property, and so if it's set to true, we're going to get almost this fuzzy look here. And this obviously isn't something that we're looking to achieve with the quality of our assets here. So as an extra measure of quality enhancement, go ahead and switch these qualities to false here in your code. Wherever you have a canvas that you're drawing to, set those to false. So then if we go back to our game and hit refresh, we're then going to have a much sharper image to work with, and that's the quality that we're looking for. So that's another important quality to consider when finalizing your asset look in your game. So in order to maximize the sharpness and quality of your pixels along with the rotation tips that have been shared in this video, make sure to set all of your canvas context image smoothing enabled properties to false. Set them off of their true default value and you'll get a much sharper look on all of your asset sprites. So to get an idea of what these rotated images might look like in action here with the higher quality that we've introduced, let's go ahead and take a look at how these green orc guys here shoot at us as we go through. So you'll see that the arrows, the quality is oh, looks like I died there, but it looks like the quality of the arrows is going to be maintained. That the sprite of those is originally a horizontal rectangle, and it looks to be just a rotated rectangle as well at arbitrary angles wherever the hero is moving in relationship to the green orcs. So thanks for tuning into this video. I hope it helps you with your quality endeavors here as you guys make your games, and happy coding.